Hello, hello. This is Concrete Path. Today's lecture is saying that let's talk about strain rosette. Strain rosette, or we say arrangement of strain gauges. Arrangement of strain gauges. So in actual practice, we say your shear deformations is difficult to find. Let's calculate only the linear displacements. So we use these strain gauges. They measure linear strain. We can say they measure normal strain. We have the equation that Ex dash equals to Ex plus Ey by 2 plus Ex minus Ey by 2 cos 2 theta plus gamma xy by 2 sine 2 theta. So in any standard equation, we have four variables. We can have four variables. One is this Ex, Ey, and one is the gamma xy, and next one is the Ex dash. So we have three normal strains. In a standard equation, we have three normal strains and one shear strain But based on the arrangement of these strain gauges, if we use only two strain gauges, they will measure, let's say they will measure Ex and Ey. That means E at 0 degree and E at 90 degrees. Two are at 90 degrees from each other. But you can't calculate the strain. You can't calculate so if you want to say at any angle theta, at any theta, get the strain, normal strain Ex dash. You can't directly say that. So before that, you have to get the that gamma xy. You have to get the gamma xy. So for that, if you directly use three normal strain gauges, they will measure at three locations. If we know this from any particular strain gauge you are applying, let's say firstly you used two strain gauges. Because of them, you are unable to find at any different theta without using strain gauge at that theta. You can't directly say what's the strain at that particular location. Before that, you need to get gamma xy, but you can't directly calculate that distortion angle measurement. You can use that strain gauges that they measure the linear strains because of that electrical resistivity change on the wire when they shorten or that elongate the wire. So for that, we use three strain gauges. One is your strain gauge in x direction. Next one is your strain gauge in y direction. That means they are at 90 degrees from each other. Third one, we directly say we would calculate the strain at any angle theta. So by measuring the strain using strain gauge at Ex dash, we measure Ex dash using strain gauge. Then after that, based on that relation, we get gamma xy. So after that, after getting gamma xy from calculations, we can get at any other location any value of Ex dash. Now Ex double dash, we can get any value of Ey double dash, we can get any value of gamma xy dash, and we can directly get principal strains, major, minor, and maximum in plane shear strain. So finally from that, then after that we can get stresses also, major stresses and tau max also. So that the conclusion is that your strain gauges measure normal strain in particular direction, normal strain. So you need three strain gauges. If you use three strain gauges, let's use three strain gauges, and then after using that equation, it will give you gamma xy dash. Yeah, gamma xy for that particular plane on which xy is located. So you got a gamma xy, then you can say get anything. Now you can get anything at any other theta, So based on this, we have different types of these strain rosettes. We say the strain rosette is a collection of arrangement of three strain gauges in such a way that they measure normal strains in the particular direction they are designed for, they are deployed for. So first one is that we call that rectangular or 45 rectangular, or we can say its special case is 45 strain gauge, 45 degrees strain gauge. So we have strain gauges. We say one strain gauge is in x direction, we call it as E0 degree. And one thing you have to remember that we for the strains calculation, we take theta from horizontal. We take theta from horizontal. But for stresses, we take theta from vertical, anti-clockwise. Here we take theta from horizontal. Theta from horizontal. This was for stresses from vertical, and for strains we take from horizontal. So we call it as E0 degree, and one strain gauge we install at 90 degrees. So along the y direction we call it as E90. And third strain gauge we are deploying it at an angle of 45 degrees from the principle that EX direction. So this is 45 degrees. So this is E45. So next to third strain gauge. Now I would say if you want to get any theta, I would write equation in terms of EX and EY. I would write EX dash equals to E45, and that equals to EX plus, or we can write E0 plus E90 by 2 plus EX minus E90. Yeah, EX plus E0 minus E90 by 2 sine cos 2 theta plus gamma XY by 2 sine 2 theta. So this equation is valid. This equation has been derived when two planes x and y are at 90 degrees from each other. You can't use the equation for these two. You can use the equation for the two if they are at an angle of 90 degrees. So EX and EY are at 90 degrees from each other. Then those are to be substituted in the equation that we have EX and EY. And it will give EX dash that we have E45. This E45 we also know from the strain gauge. It can calculate the strain along the E45 direction. Then it will give you gamma XY. Now you can get any gamma XY. So you got the gamma XY. Then after that, the question would be designed accordingly to get any other thing. You can then accordingly calculate other things also. Next type of that strain gauge is strain rosette. Is we call it as 120 degree strain rosette. Strain rosette. So you have one strain gauge along x direction, we call it as E0. And one strain gauge is at angle of 90 degrees, E90, and one strain gauge. So all angles are from horizontal. All angles are from horizontal with respect to horizontal. All theta with respect to horizontal, anti-clockwise. So this is E90, and after that we have that this is E120. This is E120. So this angle is 120 degrees, and this is our strain gauge. 1, 2, 3, and we can also make it in this fashion that you have E90, you have E0, and we have E120. This is E120. This is E90. This is E0. Then we have these strain gauges. Then we can show that angle here, its format equals to 120 degrees. And accordingly, you can calculate that. You can use the equation that EX dash equals to E120 equals to so on and so forth. Next type of that strain rosette, we call it as delta strain rosette. Strain rosette. Delta strain rosette. Delta strain rosette. So we say that let's deploy those strain gauges at an angle of 60 degrees from each other. Let's deploy them at an angle of 60 degrees from each other. Let's say this theta, this is 60 degrees, and this theta, this is 120 degrees. So this is E0, E60, and E120. So we can write the equation. We have two unknowns here. Can you guess which are the two unknowns based on the equation? If you write EX dash, let's say this is EX dash, we can write E60 equals to EX plus E0, E90, but we don't know the value of E90, so this is also our unknown. So we can write E0 plus E90 by 2 plus E0 minus E90 by 2 cos 2 theta plus gamma XY by 2 sine 2 theta. So we have the two unknowns here. you can show them that this is our unknown one, and gamma is also unknown one. So we have two unknowns, and we need two equations. We need two equations. So next equation would be for the E120. So next Ex dash equals to E120. That's E naught plus E90 by 2 plus E naught minus E90 by 2. And similarly, we have that cos 2 theta plus gamma xy by 2 sine 2 theta. Then we can get the, from the two equations, we can get the two unknowns of E naught, E90 and gamma xy. Yeah. This will also represent in terms of delta. So this is our delta. So we can say from the horizontal, so this is our horizontal E naught, and this is E60. So this is E60. This is E60. Let's make some box that shows that it is a strain gauge. Here we have strain gauge. So this is strain gauge. And this angle we have 120. So we can write E120. This angle is 120. This is 60 degrees. Then the formed shape is a delta. That's why we call it as a strain, delta strain rosette. Next one is your star strain rosette. Star strain rosette. So in this one we have three normal strain gauges and at an angle of 120 degrees. So E naught, this is 120. This is 120 degrees, and third one is at angle of 240. So this one is your 240 degrees. So we'll write it as E240, E120. So this angle from horizontal anti-clockwise, this is 240. So this is our third strain gauge, and accordingly you can write the equations. We have two unknowns. Similarly, we have here also two unknowns. Only the angle changes here. With respect to the delta, here the angle was, firstly that angle was 60 degrees, and next one was 120. Here the angles are 120 degrees and 240 degrees. Accordingly, you have to use those equations. Two unknowns are your E90 and gamma xy. Then this is the end of these arrangement of these strain rosettes. Let's talk about that. One problem we are left with, that from the Mohr cycle, or we can say stress transformation. Let's talk about this problem. We have a compressive stress of sigma, and we have a compressive stress, that tensile stress of sigma on the other face. So you need to get the location of, you need to say what is the value of tau max and the location of shear plane. So if you use the calculations, if you say what's the since we can say that on this particular plane P and Q, there's no tau is acting, that means these are principal planes. So we can say sigma 1 comma 2, that equals to sigma x plus sigma y by 2 plus minus root of that, we can say sigma minus sigma minus sigma x minus sigma y. Sigma x minus sigma y by 2 whole square plus tau xy whole square. So we got a value of 0 plus minus sigma. That means sigma 1 is, let's say, plus sigma, and sigma 2 is minus sigma. That means if we say what is the location of tan 2 theta p, or if we say what is the value of tan 2 theta p, you can say 2 tau xy by sigma x minus sigma y. So you got a value of, let's say, 0 value. So the tan 2 theta p, that means that 2 theta p is 0, or it can be 180 degrees. Yeah, we can say it's 0 degrees, or it can be 180 degrees. So we can have that. We can say both are at an angle of 90 degrees from each other. Now I want to say on what theta, with respect to what theta your tau's maximum principal stress is acting. If you analyze that from the problem itself, you would say that tensile stress is acting on Q plane. That means that means it's making an angle of 90 degrees. So we can say on the so sigma 1 is plus sigma at theta equals to 90 degrees, and this one is 0. This one is minus sigma at theta equals to 0 degrees. This is not main concern in this problem. We deal mostly on the tau max. We are worried about tau max. Let's calculate the tau max. The tau max equals to, from this calculation we have that radius, tau max equals to radius, that equals to the same value that we got as sigma. So tau max equals to sigma itself. So your shear stress maximum equals to sigma, and that the location of tan to theta, as I would say, that equals to 0 sigma x minus sigma y, minus times by 2 into tau. Tau is your 0, so we got a value of infinite, that 90 degrees to theta s. That means theta shear is at an angle of 45 degrees. Can we say that theta shear is at an angle of 45 degrees? Let's have that particular plane at an angle of 45 degrees. So this is our concerned plane, that is at an angle of 45 degrees, and we want to say what's the value of tau xy here, and let's cross check that value. I would say tau xy dash at theta equals to 45 degrees. Let's calculate that. So we have the equation. So we write minus times sigma x minus sigma y by 2, that sine 2 theta plus tau xy cos 2 theta. So we got a value of minus times plus, that it becomes positive value of sigma. So on this plane you have a tau of that tau xy equals to sigma. So similarly you can have sigma. And if we say what is the value of associated normal stress on this plane, if you say what is the value of sigma at the rate of tau max, I would say that equals to sigma x plus sigma y by 2, or we can say sigma x plus sigma y by 2, that's 0. That means a pure shear plane. Is it a pure shear plane? We can say it's a pure shear case. You might have studied the pure shear case earlier, but we have started the problem, that same problem earlier in this fashion, that we had a pure shear case. Then after that we got that principal plane at an angle of 45. Then we have some stresses, maybe some compressive, negative. It depends on the direction. So we got some one is your compressive, next one is your tensile. So it depends on that direction. Let's say we got some value of this sigma x and sigma y, and now this question was framed starting from this part. So this was kept as vertical. So I kept these stresses as P and Q on P and Q plane in this fashion, or we can say in this fashion I kept the stresses. Then after that you got this value, that pure shear plane. So if you want to plot the Mohr circle for this one, you would say that center equals to sigma x plus sigma y by 2, that equals to 0. And the radius we got as sigma. That means you draw a circle with radius sigma. So your sigma 2 equals to minus sigma, sigma 1 equals to plus sigma, sigma 1 equals to plus sigma, and 1 tau max equals to plus tau plus sigma, and your next to tau max, that equals to minus sigma. So you got a pure shear plane, pure shear case, pure shear, and we got tau max plane equals to pure shear plane, tau max plane equals to pure shear plane, tau max plane equals to pure shear plane. Pure shear plane is the plane where the normal stress is 0, and tau max plane is the plane where the maximum shear stress is there. Yeah. So let's solve for few problems. Let's solve few problems. Let's talk about that. So we got two strain gauges at an angle of 90 degrees from each other. This one and this one. So this one is your E1, or we can write E45, E30, and this one is E120. And it's given that this direction is the direction of major principal stress, sigma 1. So it's given that it's the direction of major principal stress. That means it is the direction of, or we can say indirectly we can say direction of major principal strain also. Major principal strain also. This is the same direction of major principal strain, and we call it as E0, or we can write as E1. Okay, the question says that, so your E30 is given as some value of 445 10 to the power minus 6. This is a strain along the 30 degrees strain gauge, and you have E120 equals to minus 32 into 10 to the power 6 minus 6, and you got a E value of 2.1 10 to the power 5 megapascal, and Poisson ratio 0.3. You need to get the magnitude of principal stresses. That means you need to get sigma 1 and sigma 2. So in the previous lecture we said, did you study that the relation between sigma 1 and E1 was, firstly the E1 was equals to sigma 1 minus mu sigma 2 E, and after the calculation we performed, then we convert to the, let's keep it in terms of Emax, that this same equation. Let's talk about in this same fashion. We have converted it in terms of sigma 1 also, in terms of some E1 plus mu E2 by some 1 minus mu square, some sort of equation we got. Exactly, I don't remember that. So let's talk about this one also, because this one is also derived from the same equation. So let's use that equation, sigma 1 minus mu sigma 2 E. So if you need to get principal stresses, you first need to get principal strains. And the question is saying that the direction of principal stress major is along the E0 direction. That means E1 direction is the same as that of major principal stress, sigma 1 direction. So we got that direction, and I know that this theta equals to 30 and this theta equals to 120, and that means if one principal stress is at an angle of 0 degrees, then next one would be at an angle of 90 degrees. So this one is E90, and I can call it as minor principal strain direction, E2. Can you call this as E2 direction? Then the color that's sort of red, orange, that is the problem itself, and the solution is in the form of white. So E90 direction, we can directly say this is minor principal strain direction. Now we have provided you only 2 strain gauges. How can you get those gamma xy and any ex dash? So let's see how we can get this one. See, here we have provided directly that you have a theta plane at an angle of 30 degrees from your reference point. It's directly provided to you. That means if you write that ex dash equals to E90, ex dash equals to E30, that we can say, let's keep this one as ex and E90 as ey. So we can write E1 plus E2 by 2 plus E1 minus E2 by 2 cos 2 theta. And theta we also know directly. Theta also we know, and plus gamma xy by 2 sine 2 theta. Now the thing is, if the planes are principal planes, if this is a principal plane and this is a principal plane, or we can say this is the direction of major principal stress, minor principal stress, and this is the direction of major principal strain, minor principal strain, that means on the minor principal and major principal strains, your gamma xy is 0. Is it not true? Your gamma xy is 0 on these 2 planes. So this value is 0. So we don't need gamma xy in this equation. Based on the direction given, that direction of major principal stress, we say that along that there won't be any shear deformation. So we can say gamma xy is 0. So let's talk about now. Similarly, in the fashion, you can say ex dash equals to E120 equals to E1 plus E2 by 2 plus E1 minus E2 by 2 cos 2 theta. Now you got 2 equations and you got 2 unknowns. and you substitute the value of E30 and E120, E30 and E120, and you calculate the value of E1 and E2. Accordingly, you can write equation, simplified equation as 3 times E1 plus E2 equals to 4 times 445 into 10 to the power minus 6. And the second equation you can write as that 3 times E2, 3 times E1, E1 plus 3 times E2 equals to minus 128, 10 to the power minus 6. And you got two equations, and you solve them, and you can get the value of E1, and you can get the value of E2. E1 comes out to be equals to 683.5, 10 to the power minus 6, and this one is also minus 270.5, 10 to the power minus 6. So you got the two strains, major and minor principal strains. Then you want to say, the question was that get the value of principal stresses. So we have the equation of sigma 1 minus mu sigma 2 by E. So we can use this equation also. So now we can write that this one equals to sigma 1 minus mu value is 0.3, sigma 2 by E, value of E is 2 into 2.1 10 to the power minus 2.1 10 to the power 5 megapascal. Let's calculate that, so we can keep megapascal. Finally, the stress is also in megapascal. And second one is your E2, that means sigma 2 minus 0.3 sigma 1 by 2.1 10 to the power 5 megapascal. So you can get the value of sigma 1 and you can get the value of sigma 2. So your major principal stress 139 megapascal and sigma 2 minus 15.1 megapascal. Let's calculate one more. Let's have one more problem. Let's take one more problem. Yeah, let's go. So you have a problem. We have a rectangular strain rosette. So we have this one that we call as rectangular strain rosette. This is E0, E90, and one more is at this one is at an angle of 45, so E45, theta 45, anti-clockwise from what horizontal. The values are also provided. So right, the values E45 equals to 500 10 to the power minus 6, E0 200 10 to the power minus 6, E90 equals to 200 10 to the power minus 6. This one was your 600 10 to the power minus 6. This one is 210 to the power minus 6. So we have also provided you that value of Young's modulus of elasticity, that's 2.1 10 to the power 5 megapascal. Poisson ratio 0.3. You need to get the magnitude and direction of principal strains. Find theta E1, theta E2, and you need to get the value of strain 1 and strain 2. Then after that, you need to get sigma 1 and sigma 2. So for this case, it's not given that the direction of a major or minor principal stress is given or strain. You have to calculate those directions, and that's why you have to use now 3 strain gauges. In the previous problem, we only used 2 strain gauges based on the fact that we know that along the x-axis this was your direction of major principal stress. That means gamma would be 0 here in this direction, so gamma was not needed. That means only 2 strain gauges were enough to calculate any other thing. Yeah. Now we would say we need to get theta E2. Firstly, we can calculate the magnitude. So if we calculate the magnitude, let's say I would write Ex dash equals to, I need gamma xy for this one. Because we have 3 strain gauges. That means gamma xy has to be calculated first. So let's write E45 equals to E0. Let's calculate in terms of time. Let's calculate these values only. So E45 I can write as 500 equals to Ex plus Ey by 2 plus Ex minus Ey by 2 cos 2 theta 45 plus gamma xy by 2 sine 2 theta 90 45. So this becomes 0 and we have left with 5. Then we calculate the gamma xy 210 to the power. Finally, you substitute the value of 10 to the power minus 6 also, you can get 210 to the power minus 6 also. Now you got the gamma xy. Now if you want to say what is the location of that theta strain, that principal plane or principal location, that where the major principal strain or minor principal strain is there, so we can have the equation. So let's say that the equation have equals to tan 2 theta p equals to 2 tau xy by sigma x minus sigma y, 2 tau xy by sigma x minus sigma y. We have this equation gamma xy by ex minus ey. So use the values that this one is 200 and ex was equals to, the value of ex was equals to 600 minus ey is 200. So you got the value of theta p equals to 13.282 degrees, and next one would be at an angle of 103.282 degrees. Now you got the two values. You can check the where the major and minor principal strain is acting. So firstly, you can calculate the major and minor principal strain. You can say E1 or E2, that equals to Ex plus Ey by 2 plus minus root 600 minus 200 divided by 2 whole square plus gamma value was 200, so gamma by 2 whole square. So you can get the values of major and minor equals to 623.6 and 176.39, 10 to the power minus 6, 10 to the power minus 6. This one is your major, this one is your minor principal strain. So you can write this one, E1 equals to this, E2 equals to this, major minor principal strain. So we got two values, we don't know on which theta your major is acting. So let's cross verify that. Let's select the theta p equals to 13.282. At the rate of theta p equals to 13.282 degrees, we can say Ex dash equals to the values of E0 plus E90, 200, 600, 600, 200, 600 plus 200 by 2 plus 600 minus 200 by 2 cos 2 theta p. I would write this theta p here, plus tau xy. The value of tau xy is 200, tau xy by 2 cos 2 sin 2 theta p. And you can get the value of Ex dash, that equals to 623.6, 10 to the power minus 6. So this one, that's your major principal strain, that is sigma 1 E1. So E1 is at an angle of 13.282 from this way. So we can say your major principal strain value. So major principal strain direction is along this one. So this one theta p 13.282. So this one is E1. That means at theta p here also, this theta here would be as also with respect to that 13.282. So here we have E1 and E2. Now if you want to say what is that, so similarly we can have this direction, that's sigma 1 direction, and this one is sigma 2 direction. So now if you want to calculate the sigma 1 and sigma 2, you use the equation. You can use the equation E1 equals to sigma 1 minus mu sigma 2 by E, and E2 equals to sigma 2 minus mu sigma 1 by E. E value is also given to you, mu is also given to you, E2, E1 you calculated, and sigma 1 and sigma 2 you can get. Let's take one more problem. Problem 18. Let's say you have a rosette, strain rosette. On you have a crane hook. On that you have used 4 strain gauges. So in this fashion you have used strain gauges at an angle of 45 from each other. So this one, 45. We call it as E0, E45, E90, E120, 35. E135. So we can call them as also E1, E2, E3, E4. So let's say this is E1, E2, E3, E4. So value of E1, E2, and E4 is given. This value is 120. This one is 420. This one is E2 equals to minus 45. Minus 45. E3 I don't know. E4 it's provided to you 165, and all those are in micron meter. That micron meter, not meter, micron. That 10 to the power minus 6. That means 10 to the power minus 6 micron. Similarly, you have micron, micron, micron. So you have to calculate E3. You have to calculate E3 strain along 90-degree direction. You have to calculate this one, and after that you calculate E3. Then you have to calculate. Yeah, let's calculate first E3. Let's calculate E3 first. So this value we can say this is E4. This one is 45. This one is 90, and this one is 135. So we can say your E3. If I say E3 and E1 are at an angle of theta of 90 degrees. Similarly, you can say E2 and E4 are also at an angle of 90 degrees from each other. Can we say? So this angle is also theta, 90 degrees. Yeah. So I need normal strain in that 90 direction. So if I say I know the strains in all other three directions, if I use that concept of strain, if I use this concept of strain invariance, strain invariance concept, strain invariance. So I can say Ex dash, Ex plus Ey equals to E1 plus E2 equals to Ex dash plus Ey dash. So these two are both are at an angle of 90 degrees. The two should be at an angle of 90 degrees. So if the two are at an angle of 90 degrees, I can get this equation that summation is also constant. So if I write now E1 plus E3 equals to E2 plus E4, now I could use the equation, and I can use the values also, and accordingly get the value of E3. So E1 equals to 420, and E3 I don't know. E3 I don't know, and equals to E2. E2 is minus 45 plus E4. E4 is 135, and you can get the value of strain along so strain along 90-degree direction. So strain E3 equals to minus 300 micron. Minus 300 micron. So we got the strain along the third direction. Now the next problem in this one is that get the major strain, major principal and minor principal strain, and also get the gamma max in plane, maximum sharing strain in plane. So E1 equal E2, we know equation, E1 E2 equals to, so but if we don't know the gamma xy, we need to get the gamma xy also. We can't use the equation. Let's say E1 E2 equals to, let's talk about, we can select any two. We can select any two. If you want to select E90 and E3, E1 is up to you. And similarly, you can use E135 and E45. The two should be at an angle of 90. So if you write E1 plus E3, no, let's keep the sign in terms of theta. Let's say this one is your E0 plus E90 by 2 plus minus E0 minus E90 by 2 whole square plus gamma xy whole square. So I know the value of E0, E90, but I don't know gamma xy. So for that you need to calculate the Ex dash. Let's calculate Ex dash first. Let's say E45. I know the value of E45. That's E45 value was equals to minus 45 micron, and then that I can use the equation E0. The value of E0 was 420 plus E90. E90 value was the value of E90 equals to minus 45. Yeah, the value of E90 I calculated as E3, so I got the E3 value of minus 300. So E0 was equals to 420 plus minus 300 divided by 2, and plus minus root of E0 was equals to 420 minus E90 was equals to minus 300 divided by 2 whole square plus gamma xy, and by 2, here we have gamma xy by 2 whole square, gamma xy by 2 whole square, gamma xy by 2 whole square. So now we can get the value of gamma xy, that equals to minus 210 micron. Now you got the value of minus 210, you substitute in this equation. Now you can substitute the value of gamma xy here, minus 210 by 2 whole square. Then accordingly you can get the value of strain 1, strain 2. So strain 1 equals to 435 micron, and strain 2 equals to minus 315 micron. And similarly, if you want to say what's the value of gamma max in plane, gamma max in plane, that equals to 2 times r, radius equals to gamma max by 2. So gamma max in plane equals to 2 times r, the value of radius equals to this root. So this is the radius, so 2 times that radius, and you can get the value of that, we can get the value of 750 micron. 750 micron. 750 micron. 750 micron. And one more problem is that a problem that says you have a desired plane. So this is our some stress element or strain element. Let's say this is some element. So we need to get the values of strains. You have to calculate the strains Ex dash and gamma xy on this plane. That's making an angle of 40 degrees with respect to vertical, and you need to calculate strains. For that, you have strains. Let's say this is y direction, this is x direction. You have strains in x, provided values are Ex equals to 710 to the power minus 6, and strain in y equals to minus 900, let's say micron, and gamma xy for this plane, xy plane, we have minus 450 micron. And you need to calculate the strains along that 40 direction and gamma xy and Ex dash. So, but we know that for strains your theta should be with respect to horizontal. Theta with respect to horizontal. Theta is with respect to horizontal. So if this is horizontal, you have this theta now. So your theta equals to 90 plus 40, that's 130 degrees. 130 degrees theta. And now you have the equations. You can say Ex dash, or you can write E135. 130 equals to Ex plus Ey by 2 plus Ex minus Ey by 2 cos 2 theta plus gamma xy by 2 sin 2 theta, and you get a value of Ex dash equals to some sort of value that equals to 0 minus 0.1733 10 to the power minus 6, and you can get the value of gamma xy by 2 dash also. So you can write gamma xy dash x dash y dash by 2, that equals to minus times Ex minus Ey by 2 cos 2 theta sin 2 theta theta value 130, and we have gamma xy by 2 gamma xy by 2 sin cos 2 theta, and you calculate that also, and you get a value of gamma xy dash equals to 165.38 10 to the power minus 5. Now, if you want to say what's the location of principal plane or shear plane, if you want to say what is the location of shear, that where the shear strain maximum would be there, that maximum shear strain plane, that's same as shear stress plane, maximum shear stress plane. Let's say that value equals to tan 2 theta is equals to, we know that the equation was sigma x minus times sigma x minus sigma y, so we can write E naught minus Ey E90 by 2, and we have gamma xy by 2 also. So we have this equation, so you can use that. E naught was equals to Ex. The Ex value was 450, that 700 value. So 700 minus of minus 900 some value, 900 minus 900, and divided by gamma xy. The value of gamma xy equals to minus 450. So minus 450, and you can get the value of shear plane. So theta s equals to 37.15 degrees. That means theta on this plane. So we have some plane making an angle of 37 degrees. So this is some plane that we can say this is your gamma max plane in plane. That means add some angle of theta that equals to 45 from this plane gamma max in plane. So this was your 37. So somewhere 37 plus 45, that means some 1890 degrees. So somewhere 37 plus 45, somewhere some value of this is your theta p location. You can say E1 location or E2 location. You can write theta p. This is our theta p. So this is the end of that Mohr cycle strain transformation and stress transformation. Now next topic would be about the theories of failure. Let's have the lecture end. Thank you for watching this lecture. Thank you.